I believe all of us have heard of the artificial intelligence nowadays because artificial intelligence is changing the world. It's very, very hot. For instance, artificial intelligence is enable a car to drive by itself. AI can play the Go game that beats the world champion. And AI can recognize the face of our iPhones. And AI can translate our speech into English text. And very importantly, artificial intelligence can read the medical images and make a disease diagnosis. And most recently, artificial intelligence make a big scientific discovery revolution by folding protein from sequence into structure. Then, what is artificial intelligence? Artificial intelligence is a technology that enables the computational devices to gain some sort of the human intelligence, like speak, like read, and most importantly, learning, because learning is the key capability to gain other intelligence. And then machine learning is an area of artificial intelligence that enable computers to learn from data, just like how we train our kids to learn to speak, to write, and so on. And deep learning is the most powerful machine learning technology that mimic human learning. Now, I use one example to demonstrate why it's so powerful. Use a face recognition example. Here, give an image of the face. Human brain first sees the dots and lines. Then from these dots and lines, then we see the triangles and the circles and the squares, those kind of higher level geometric objects. Then we continue generalization, we see eyebrows, mouth, nose, until we recognize the face. And then we like to use computer deep learning to mimic this process. We first have the list of nodes to represent those pixels. Then we have another computational nodes to recognize lines and dots. Then we use this as input to generalize to recognize the triangles, circles, and squares. We continue this process until we can recognize the eyebrows, mouth, and nose, until we can make a decision, this is the face or not. And this network needs to be trained in order to recognize the object. Now I use iPhone face recognition as an example. For instance, you get a new iPhone, right? You show your face to your iPhone, then your iPhone learns from that, recognize the geometric objects of your face. Then after that, we need to test it to make sure it works. Then I show my face to it, it should open the iPhone. If I show your face, Sheila, your face to it, it should not do that, right? So then if this is the case, then I trust it can make good predictions. Then in the future, whenever any person shows a face to it, if it's me, it's going to open it, otherwise it's not going to open it. That's the prediction. Now, I'd like to show how this technology can be applied to solve a major scientific problem. That is called a protein folding problem. We know protein is a sequence of amino acids. Amino acids are the building blocks of the protein. And this sequence must fold into three-dimensional shape in order to carry out all kinds of biological function, like digest food, fighting against virus, generate energy, and so on. So it's very important to know the 3D structure of the proteins. So it's very important for us to understand the disease mechanisms, because many diseases are caused by the misfolding of protein structure. It's important for us to design new drugs, because most drugs interact with proteins. And also it's important for us to design new proteins that can do more than natural proteins, for instance, generate some energies. And of course, it's very important for precision medicine because we need to find the drugs that work on proteins in individual persons. So a lot of effort has been put to produce the protein structure from sequence. Statistics, physics, but most of them didn't work. But recently, a key revolution has been made in this field is by deep learning. So the basic strategy is very simple. Suppose I want to determine the shape of three points. If I know the distance between them, then I can identify a unique triangle to represent the shape of those 3 points. The same idea can be applied to protein sequence. So I give a sequence of amino acids. I first use deep learning to predict the distance between any 2 amino acids. Then I use this distance information to build a 3-dimensional structure in order to satisfy this distance. Now here is deep learning architecture we use to predict the distance between amino acids. So the input is the pairwise information between amino acids. This input is used by deep learning to extract the distance-related features. Then finally, deep learning uses those features to predict the distance between any two amino acids. And we train these on the proteins with known structures. Then we can apply it to new protein whose structure is unknown. Now I'd like to show you, once we get this sequence and its predicted distance, then we can generate three-dimensional structures satisfy this distance. Now I'd like to show you one video to demonstrate how this works. So give a sequence of unfolded proteins, and these dots represent the quantity of this structure. Then the computer started fold this protein into three-dimensional structure, and it fits the distance better and better, so until it reaches the best fit. That is the structure we are looking for. That is close to the real structure. So here, I'd like to show you one example we did in the 2018 Worldwide Protein Folding Competition, CRISPR 13. So for this protein, the green represents the true structure, and the purple represents the structure we predicted using deep learning. So you see they are superposed very well. The score is 0.8, close to 1, perfect score. And once we get these structures, what can we do? Just like Raghu did, we actually can help us design the drugs. So once we get a 3D structure, we can screen all kinds of drugs that may bind to this protein to treat a disease. This would be much better than randomized, traditional trial and error kind of the drug design. Potentially can reduce the drug design time from dozens of years to several years. And we are getting better and better at predicting the structure of the proteins for drug design. So here is the top 20 predictors in the 2018 Worldwide Protein Structure Folding Competition. So our group, Mizu Marticon, was ranked among top 3, along with the best, one of the best artificial intelligence lab in the world, Google DeepMind. And thank you. And more importantly, Google DeepMind used a strategy that had been pioneered by my group and several other groups in the field. With that, I'd like to conclude my talk with several comments. Firstly is, artificial intelligence is revolutionizing every sector of our society, from communication to transportation to entertainment to healthcare, many, many areas. And deep learning is the key technology to solve scientific problems and engineering problems. And we are forming a deep learning center to facilitate the research in this area. And artificial intelligence will have more and more impact on our society. This is just starting point. So US just initiated AI initiatives. So many countries are competing in this field. Many universities try to excel in this field. And we need to work very hard to become a leader in this critical area in 21st century. Thank you.